Welcome back to our Scala class. Today we'll continue talking about object-oriented programming, and the second part we'll talk about private and public data, variables, values, and also of course methods. Right? Not much about protected today. So the idea is that maybe there's some data. The main idea is something called data hiding. So we might not need to show everything to the outside world. We don't have to show everything to the outside world that is inside our class instance. So when we create an object, maybe there's some things, some private things we don't need to show, but we still need them to do our work. So let's take a look at an example. So let's take a look here, right? So far, let's look at it's in our day 12, right? We have a house, right? And we have some, these are basically actually parameters which we add to our, then fields are created here, right? So, but we can access them, right? So, we can do, let's do an age, for example. Maybe we can do value, we'll create a variable var, right? Age equals 0, right? So, this means, of course, this we can change it, it's mutable, right? So we can change the age, mutate, right? Mutate, change the age later, right? And from outside, from anywhere in the world, right? So, right, later, right? So, but it is not, so we don't really have a way of setting, we decided for purpose of this house that all houses start at age 0, right? So, how are we gonna use it? We can, of course, print line, right? Print line, let's say stra house, right? Of course, all other, you see age, it's already here, right? So, we can print it, it should be 0. Yes, age is 0, right? And of course, I could do things like, for example, I could do even things like this, plus equal, say 5, right? And so same as saying stra house, age equals stra house age plus 5, right? So I can do it because it's mutable, right? So, and of course, if I print it, right, it's just a value, right? So I can adjust it, right, later on. So it's public. So this information is public, and maybe this is not such a great idea, right? That we this easy access, maybe we want to have something a little bit more controlled, right? So what, in order to do that, right, we can have a maybe okay, so age will remain public, right? But we can do maybe some information we don't want public, right? So we can do I'll do private var security key, right? Security key, right? And I will say for now it's not known, right? So right, it's not, we're not using it. So now we limit the visibility of this security key to inside our class, basically, right? Outside it will not be visible, right? So when we create the object, so what does it mean? This means that it can be used inside, meaning our methods, and we have inside, we have access to it inside, but we don't have it inside. So our methods, our methods can use it, right? Right, inside, right? So private var. So what do you think? Can we print it? Well, print line, stra house, right? On, it's not here, right? There's no security key, right? So because I use the private word keyword private, right? So private. So well, then okay. So what good is that we can't use from outside? Well, we can do it as set. We can have, of course, a specific setter, right? Obtain, update, maybe we'll call method, right? Again, so starting construction, of course, we can actually, you should probably put it here already, here. We should move it here, basically, right? Starting construction. It's still correct, right? And we start construction. So private var, right? Can we go back to? We can have also public. Again, we can do a public one again. Say val public key, for example. We could do, of course, maybe we have a public key, right? For I don't know, for somebody, my publicly, right? We can mix and match. Public key, right? We can mix and match, unlike some other. So we can mix and match, right? Again, so there's no order, right? Of course, you should, but better to organize in groups, right? In private and public groups, you know, sections, groups, right? So of course it'd be better to use it here, right? But again, you can mix and match in Scala, right? So, but we have a private security key, right? And we would like to do something with it, right? So what we could make a method. So define update or create update security key, we'll call it, right? More or less, right? And like maybe we'll call it update something like password, maybe, right? Password, I don't know, password string, right? Of course, it'll be hash, right? And we'll do something like, we'll do some funny stuff, right? And we'll return, we don't have to return anything, right? This is one of those object-oriented things. Usually in object-oriented programming, we don't return anything as part of notice. What we are going to be doing, we are going to be updating stuff inside. In this case, we're going to update security key, right? That's what we said here. So what we'll do is, I'll say security key, right? Is maybe something like you know, equals password plus, I don't know, plus myself, for example, right? Again, just something silly, plus hash my password, maybe, you know, hash password, right? And then myself, right? So of course, this actually we would have to in real life we would call more functions to do work. In fact, we will maybe get to that as well. So now maybe we could do, of course, retrieve, right? Retrieve security key, right? So we can update and we could retrieve security key, right? And maybe I have some, well, not for everybody, again, maybe I'll have a password, right? Maybe, right? Something, right? And we could, you know, maybe not print it, maybe we can print it. We can do it maybe string, right? Of course, this is not then if, you know, if password is okay, right? If password is if password equals hunter2, right? Password equals hunter2, right? It's a little old joke, right? And then we return the actual. Then we do give the security key, right? Else we give, you get nothing, right? Else no access, right? Something like that, right? Okay, so we get string, right? So if password is counted, of course, this of course is you know, a joke, right? So you know, match of course should be of course to do we have another function. At some point you have to do, of course, verification, right? So so we have these two methods, right? To update and retrieve the security key, right? So now, of course, I have access to this security key, right? I can update it, right? And I can retrieve it, right? Of course, with a password, with a silly password, right? So let's check, right? So now I can do strawhouse update, right? See, update security key. I'll say maybe I don't know, 1, 2, 3, right? And very smart, right? Something, let's say something, well, again, let's stick with 1, 2, 3, 4, 5, 6. Very smart, right? My password, my password, right? And so, well, it will update, and then I'm going to do print line, strawhouse, retrieve security key, and I'll do hunter2, right? Of course, since I'm so smart, of course, you should not generally. You should not enter passwords in code, right? You should probably ask, it should come from some configuration, yeah. And also, of course, print line, I'll do Control D, right? I'll do bad, not the password, right? Not the password. Maybe I'll try, you know, not my password, right? So, and we'll see, of course, this will retrieve this password, and this will retrieve no access, right? So let's see what happens, right? So we have this, we have set, in effect, we have a setter method, right? We are controlling this, what we are doing with the security key, right? Again, how often do you need this private? Again, it's anytime. You don't really need, you see, okay, does anybody outside need to use this function or this data? Is it only, do we want to control it more, right? So again, we have some controlled access, basically. Let's see. So what we should expect, right? So hash my password salt, I got the actual security, so I got it out, right? Retrieve, no access. Of course, what you give, maybe give empty string maybe, or something like that, right? So now we have, so that's how you could work inside. So inside methods have full access to this private key, right? Inside the house, right? Inside the house, like the poor guy here, right? Well, he only gets to have these approved methods who do the work for him, right? So again, but how about this guy here, right? So again, even if it's public, you could still probably do, we could add a method, maybe we could write a method, again, update, you know, years pass, years pass, right? And of course, let's say years will be integer, right? So of course, as part of this function, right, method, we would do, again, we would do age plus equal years, right? So integer, right, works, integer, right? So years pass, right? So we could use that, of course, instead of this, right? So we could do stra house, years pass, right? Maybe 15, right? 12 years, and we will see that this is actually right. So again, for most things you don't really need to, since you don't need this complicated thing. Like this is in Java, you have to do almost these setters getters by hand for almost everything, or use IntelliJ tools to generate these. In Scala, they are already pre-made, right? So the security is not that often needed, right? So, well, again, you can do this also later if you see, okay, there's some method you're only using inside. For example, maybe there is a function which generates hash, like this part here, right? Could be internal. So we could also do even maybe, so go crazier, private, right? Def generate hash, right? From password, right? String text, right? Plain text, right? Plain text, right? String, right? And we would call a hashing function. It would get you a string, right? String, right? And we would do something like, generate hash. And, well, and we need, of course, we'll do this something like this, right? So instead of this, right? I would add here again one more level of misdirection, right? So basically, right? Plain text, right? Right. Of course, in real life, in a real hash would actually, encrypt the, hash, the plain text, right? So, but of course, I don't want to run the function right now. Look for a function, but so here basically I would call this generate hash, right? Generate hash, and I would do password, right? So again, so this is not publicly, so this is private. So we can do private methods as well, meaning they are only usable by internally, right? Not from outside, right? Okay, again, for local use, right? For internal use, right? For example, for this public, again, so this is how, like I said, you hide the complexity, right? So we assume this generate hash, right, which is encryption for this password is not needed, right? Then for public doesn't need to know about this, right? Meaning when I say public, of course, I mean possibly another developer, right? You create this class, you give it to the developer, and they only need these in order to use this class. They only need to build new houses, right? They only need this update security key, retrieve security key. They need pretty print. Maybe they need a toString method, right? And some other things they need, but this internal generate hash is not for them to use. Basically, you're saying, okay, we need this locally, right, internally, but you don't use it from outside. So again, as you can imagine, right, everything will still work, right? But I don't have, right? Again, I don't have so I don't have access straw house, right? I don't have access to generate hash, right? Because it's private, right? So no access. So no access to generate hash method because it is private, right? But it's used locally, and I can still use it. The code will still run. Of course, again, in this case, right, everything works, right? My years pass, right, and my age has been, the house age has been changed. Here you can see here, and also, so we change the password, right, and we either have we can retrieve the security key, or we can have a no access response. Of course, again, in this example, we just added more levels of this abstraction on top, but of course we didn't really gain too much, right? Because of course the code is so short. But still, what did we gain? Of course, we gained very well regulated method calls, right? We say here retrieve security key, right? We don't just allow, because there could be more code, there could be more validation, there could be more code here to check for access, right? Privileges, right? Maybe you have to call a database, maybe you call a database, maybe you call some network security. Lots of, it could be many different levels of security you could add here, right? So again, so it is again, it's more modular, right? You create a class which creates these objects. Again, inside these objects you have well-defined interfaces, right, which let you basically you have a well-defined procedure, basically, which let you do things with this data, but some things you just don't let outside the world to see. Okay, again, so private and private, when we say private, this means it's for internal use only, right? Okay, so we have the public age, right? Let's add one more thing is so age, okay, we don't change. We could also do something. Let me we have some time still, right? Let's check how much time we have. Right, we are going, yeah. So let's add some more parameters here, right? So val, right, we have material. Let's try to generate some volume or cubature, right? So let's say we have levels, right? Let's add meters per floor, perhaps. Floor height, right, would be, and we add, this will be an integer, a double, right, will be 2.5 meters, for example. No, let's say 2.8 meters, right? 2.8 meters, right, comma, we need to add a comma here, right? And then height, and let's assume, right, let's assume we have a width, right, will be maybe again double, and let's assume all houses start by default 4, and length, right, width and length, right, and length, width and height, and yeah, width, height, length, right, length will be maybe 2.5, very small house, right, maybe val length. Well, of course, kind of careful with length, of course. Remember, has nothing to do with your length methods for built-in lengths, right? So I'll call it house length, maybe better, right? House length, right? Because so you have less chance of being confused, right? Let's say maybe 3.7, right? So, okay, so we have all these levels, right? These are pre-built, right? But and they're all going to be set by default. So we, of course, we can generate some data here, right? And let's do something. Maybe we want to have a cubature, right? So why why have, if you're going to have all this information, we have levels, right, floor height, right, floors basically, right, width, house length, right, we could calculate volume, right, so how could we do it, right, we could do it here, right, so I'll do I could do volume, but volume is not such a great name. Why? Because volume you can get confused. It has too many different meanings. I would say cubature would be better. Cubature. Can we say that? No. Let's see. Rename to curvature. No, maybe you can't say it. So I guess we have to call it volume, right? I would say kubatura in Latvian. So volume. Okay, we'll stay with volume, right? On the volume, right? That's on. So what it's gonna be? It's gonna be levels, right? Times floor height, right? Times width, and times house length, right? So for, right, how many floors, right? Floor height. So probably levels and floor height. You probably want to rename levels to floor, right? Floors, right? How many floors you have? Of course, this doesn't mean, of course, we're not talking about nothing. So of course, this does not cover attic on the basement, of course, right? So, but we'll go with it for now, right? So this is public, right? This is public volume. So you might have, so when you should you set values here, when you should set them here. So, well, argument is if you are going to, if you don't need to initialize them, or maybe they're initialized if they're based on something else, right? It would be redundant to have a volume here, right? Because you are going to calculate. It depends on all these information here, right? So you can do it immediately when you start your construction, your constructor, right? How about age? Again, if you're always going to start with 0, right? Then you don't pass here. You put it here, right? So, okay, what else? So var, right? One thing is private val. Well, we could do a private val as well, but then we have to initialize it immediately again, right? Otherwise, how are we going to change it? Because it's a value, right? So you probably want to do that as well, right? So how many parameters do we want? Well, 7 is already 6 or 7. That's already quite a bit. 10 probably is already getting maybe a little bit too many. If you have many similar parameters, of course, you can pass them as sequence, some sort of data structure, more complex structure, right? We could also add a requirement. You want maybe a list of all the bricks used in the house, right? You could have that as well. We are getting a little bit silly right now. So volume, right? We can use it to calculate from here, and I can, of course, the volume is, right? I can run it here, right? My volume, print house, print line, straw house volume. So I'll do this straw house volume is, of course, I can do this straw house dot volume, right? Easy, really easy, right? So quite nice. Once you set it up, again, so going to back to our last thing, which we'll discuss more after in a live coding session. So here we have a house, right, and we get the volume out of it, right? Let's see how much it will be. It will be probably something we want to round. It will probably be something with a 41.4. Okay, very nice, right? Not too bad, right? So I assume the math is correct. We have 2 levels, right? No, how many levels? We only have 1 level in straw house, right? Right, so that's actually even easier, right? So something like 4, 2.8, 4, 3.7. Of course, I could change. Now I could change it. And if I add something, my straw house, I could add maybe width or house width, right? House length would be maybe only 3.2, right? That's also completely legal, right? I could add this material, right? These parameters. Again, if I forget the order, right? I don't have to add all of the parameters. I do not have to add all the default parameters, right? I can specify which ones, right? So here I specify explicitly. These are implicit, right? Because I start with piggy house, that's first one, right? So IntelliJ tells me, okay, that's piggy house, okay, yeah. But of course I had to do this. These 2 are required. Why? because I have not made default. I could have, right? I could have said all houses are called house name, right? I could have made them default, which actually may be completely fine. Maybe all houses, if you're making lots of houses, right, and they usually, your clients want a 2-level house, right, 2-floor house, you add 2 here, right? And then you save some time for it in future, again, and you don't lose any of the flexibility, right? So use default values as much as possible. So that's another takeaway. Okay, so that is actually the main, all of it for the basics of the object-oriented programming. So we make data, right? We can store more complex data here as well, right? We can use not only just primitive strings and integers and doubles, we can use, of course, our sequences. That's also possible. And what else? What we're gonna still need to look at? We're gonna need to look at objects. Well, so we can actually do object right now. So what is this object? Basically, it's so-called singleton object. So object in Scala is so-called singleton object. Basically, we have said that we are only going to have a single instance from day 12 classes definition, right? So only one is available, and it's already here, it's already done, it's already available, right? So in fact, we've been doing, right? This is basically the day 12 classes. We have created an object already, right? And this is basically the constructor, right? This is our constructor because it always runs when we create it, right? And that's what we have. We'll see it's not that completely simple because we're using extends app. That's for maybe probably for Thursday for next lecture, right? We'll see that. But in effect, right, this means that we only have a single object, right? Here, right, and I'm using a class definition, right? A class. This means I have still ability to create as many objects of this type as I want, right? Here I have said basically that this data 12 class is only going to be one. There's only going to be one instance of this object, and it's already there, it's already created basically, right? So a little bit of syntactic sugar. Okay, so next step is probably to practice a little bit of objects, of class creation and creating objects. Thank you.